for this problem, it's a 1x1 plate. So this is like a square, so 1 meter, and this is 1 meter, and with the height of 1 centimeter, so it should be 0.01 meter. There's a force on the top, and there's oil in it. And when the ux at y equals to 0.01 meter is 10 meter per second. When ux at y equals to 0.00, which means the bottom meter, is 0 meter. The question wants to know how much force is required to make this happen. So we can use the viscosity equation we learned today. Mu equals to tau over dux over dy. Sorry about the writing. It should be dux and this is dy. We can break the tau, which is the shear stress, down to F parallel force over A over dux over dy, which means the gradient. So right now we have known the area. The area equals to 1 multiplied by 1 meter multiplied 1 meter equals to 1 meter plus meter square. We know the viscosity. Viscosity for this one should be 0.08 Newton second per meter square, which is the viscosity for the oil. So we can also use the relationship between ux and y to know the delta ux over delta y. It should be 10 minus 0, 0.01 minus 0 from top to bottom. Second power of negative 1. So this is the meter per second. This is the meter. So we can erase this down. So the final result will be 1,000 meter, 10,000 second with power negative 1. We can use this to estimate the gradient in this question. So now we have known this, we have known the area, and also we have known the estimation of gradient. We also know the viscosity. So now we can solve for the force. The parallel force over A equals to mu multiplied the du. So this time it shouldn't be dux. It should be delta ux over delta y, and we multiply A for the both sides, so F equals to mu A multiply delta ux over delta y. So we can plug in number 1, 0. So this one should be 1,000. So it should be 1,000. The unit is Newton. So the final result will be 80 Newton. For this question, the key idea is the most important thing is we need to know the equation, also the idea of viscosity, which we use this equation so we can solve this problem. It connects the force, area, gradient, and the viscosity together. This equation is very important. We also need to know how to estimate the gradient with the changing of the ux over the change of y. We also need to realize that the ux is not velocity, it's velocity field. We have to understand this problem. We have to understand this key concept to make sure we can solve this question. Thank you.